Okay, class, welcome to the video of 8.2. We're going to be talking about integration by parts. So throughout these videos, as I'm making them, I'm not going to do all the whole lecture at once. I'm going to do it per slide. So this is just the introduction. This is going to go over what this integration by parts is, where it comes from, and what it's all about. Okay, so I'm going to just go ahead and jump right in. So the goal, this is the goal. The goal is, all right, is to take the integral, okay, find or take the integral. Now that's too thick of a pen. Let's try a different capacity here. Let's try with something a little bit, take the integral. No, a little better than that. Okay, there we go. Take the integral involving products of algebraic and transcendental that's a C, okay? Transcendental. Let me try to spell that one more time. Transcendental functions. Okay? So that's what this is about. So if you notice here, look at these three integrals here. Okay? Go back here. I got integral 1 here. I got integral 2 here. And I got integral 3 here. Okay? Notice there you got two functions being multiplied. In integral 1, I have x times the natural log of dx. Okay? And in integral 2, I have x squared times ex dx. And integral 3, I have ex times sine x. See, you're taking the integral of products. You're taking the integral involving products. And so in 8.2, when we talk about integration by parts, this lesson is going to teach you how to take the integral of those type of integrals, okay? And so the method that we're going to be using is called integration by parts. Okay? So where does it come from? Well, it comes from talking about the derivative of products, the product rule, okay? So remember, when we took the derivative of two functions being multiplied, u times v, we did the product rule, right? It's going to be the first times the derivative of the second plus the second times the derivative of the first. Okay? So, and then, of course, I'm going to rewrite this. Instead of using dv dx and du dx, I'm just going to go u v prime plus v u prime. Now, remember, these derivatives are all in terms of x, okay? We're just using this u and v just to simplify the notation, but everything's in terms of x. So what I'm about to write, don't let it confuse you. Now, if I want to take the integral of a product, I'm actually taking the integral of this, okay? Because this comes from two equations or two functions being multiplied, right? So therefore, if I want to undo or take the integral, I'm taking the integral of this, okay? Because the integral of this is the same thing as take the integral of a derivative of a product. So therefore, uv, if I want to get back uv, right, then all I got to do is take the integral of uv prime dx plus the integral of v u prime dx. Okay? And so, what does that give us? Well, that gives us uv is equal to the integral of u dv plus the integral of v du. Okay? I'm trying to write a little bit better than what I'm doing here. So u and v. Okay? So u times v is equal to the integral of u dv plus the integral of v du. So it comes from taking the integral of a product being derived, or the derivative of a product, okay? So that's what gives me back my uv. So it comes from the product rule, okay? And notice, so what they do, so from here, we get this theorem, okay? How did they get this theorem? Well, if you notice, they took this piece right here, which I'm boxing in red, and they subtract it to the other side. So they subtracted it over to the other side to get this. Okay? So this is what you call integration by parts. All right? So the theorem says if u and v are functions of x and have continuous derivatives, then the integral of u dv is equal to uv minus the integral of v du. Okay? So this is where the integral comes from. Now, what it comes down to is this, class. When we're doing this integration by parts, we have to decide what's going to be our u and what's going to be our dv. Okay? That's where majority of our work is going to come from. What's going to be my u and what's going to be my dv. Okay? And the way I'm going to find out is I'm going to use this little acronym called LIATE. Okay? All right? So my u is what comes first in this acronym. My dv is going to come second. All right? So the L stands for log part. This is the log part, the logarithm part. Okay? The I stands for inverse trig part. Okay? The A stands for algebraic part. The T stands for trig part. Not inverse trig, just trig part. So trigonometric part. And last, E. I'm going to run out of room here, but I'm going to just kind of write it over here. E is going to stand for the exponential part. Okay. So this is a pretty good little mnemonic to help you determine which is going to be your u, which is going to be your dv. Your u is going to be the first one that's on the list, okay? Then your dv is going to be the one that's second. All right, and I'll show you what that means, what I mean by first and by second as we work problems. But this is the introduction. This is where this integration by parts comes from. So remember, what is the whole goal here in this 8.2? The goal is to take the integral involving two functions multiplied to each other. Taking the integral involving products, okay? That's the goal, all right? So I will be making a video going over the first example.